Hi everyone! Hopefully all of you can see me, all of you can hear me. My name is Cami Williams. If this is your first time checking out the YouTube channel or checking out the stream, thank you so much for coming. Today we are going to continue to build our web application connected to our PyTorch model through AWS SageMaker. Woohoo! Yay! Before I do that, I want to give a shout out to a couple of people. Mal, hi from Beijing. Nice to see you. Thank you so much for joining. That means a lot. Also wanted to shout out Brian. Talked to him yesterday. He was excited about the stream, so hey Brian. And then to everybody else who's watching, thank you again so much. So let's dive right in. Before I do, as always, please subscribe. Please follow the Twitter page. I think I linked it in the description. Now I'm questioning everything, but whatever, let's just keep going. So let me switch over to our desktop. Before we get into the SageMaker stuff, I got a couple of tweets and a couple comments asking people what the PyTorch cheat sheet was in my bookmark bar. This is from a community member from PyTorch. His name is Simon. I'll link it in the chat right now, and then I'll be sure to also share it in the description after this. But essentially, it's your PyTorch cheat sheet. Granted, it is PyTorch 1.2, and I believe the most recent release is 1.5 or 1.6. So keep that in mind. Some of these things might be a little bit dated, but I use this whenever I am looking for a quick fix in PyTorch or a quick answer to something. This has a lot of really useful information. So go ahead, check it out if you're interested. It has all of the domains, so Torch Audio, Torch Text. It has these NumPy configurations too, which are really helpful if you're familiar with NumPy. Also, Simon's website is nice. He has blog posts about various AI ML stuff, but then also things that he is currently interested in. So shout out to Simon. Thank you so much for creating this. It's something I use, and then something hopefully all of you will use in the future as well. Okay, let's get back to where we were before. So if you're following along, I wrote this blog post a few weeks ago that kind of gives a step-by-step on how all of this is done. You can go ahead and take a look at that. But really quick, just as a refresher, we are hosting our PyTorch model on AWS SageMaker. We are connecting that SageMaker endpoint to a Lambda instance and then attaching that to an API gateway REST endpoint. So that way when we host our web app, we can just call that REST endpoint, send data to SageMaker, have the PyTorch model give us a response, formulate that response through Lambda, send it through API Gateway, and then the web app can react. What we did in last week's video is we started to set up our SageMaker endpoint. I hit a bug at the end, which turned out to be ridiculous, but I'll share with you guys the solution anyway. So today I want to wrap that up and then get started creating this Lambda function. So hopefully all that sounds good. As always, I want to set a big disclaimer saying that utilizing anything with AWS can cost money, especially if you pass the free tier. So for me, for example, I didn't turn off my SageMaker instance since last week, so I've accrued some coin on my bill. Make sure that you turn off anything that you don't use. Make sure you know everything that's running so that way your bill isn't huge. That said, AWS customer service is great, so you can always give them a call if there is an error or if you accidentally made a mistake, and they'll usually remedy it for you. If you're interested in an introduction to PyTorch or contributing to PyTorch, I recommend checking out my previous blog posts that explain just those things. An introduction to PyTorch by someone who doesn't know a ton about PyTorch, and contributing to PyTorch by someone who doesn't know a ton about PyTorch. That person is me. Just want to say I'm not a researcher. I'm just a hobbyist generalist who has a good time tinkering with stuff. So if all that sounds good, looks like big bill, that's a big bill. Yeah, my initial go at this was ended up being about $300, which was way too much. I ended up experimenting with a lot of things to try and get the cost down as much as I could. And of course, as I mentioned before, I didn't turn it off when I was done using it. So when all was said and done, when I wrote this blog post, the final output was about $30. But again, that was me testing a lot, not turning things off. And so it shouldn't cost you much more than that. But again, as always, wanna shout out that disclaimer. Also in this blog post, might as well link it as well. This is the blog. I believe it's linked in the description. But then here is a Medium post, 7 ways to reduce your AWS bill. Always good to share that information with the fam, right? Okay, cool. So we are hosting our MNIST model on SageMaker. We are going to deploy it and create a SageMaker instance, and we are going to start to build our Lambda function by 1 p.m. PST. If that sounds good to you, let's dive right in. Okay, so playing catch up, this is my SageMaker instance. You can see it's in service. It has been in service since August 5th. I really haven't touched it at all except for the 2 minutes after the stream had ended. But let me just show you the lay of the land. So if you are following along with your SageMaker instance, you can click on Open Jupyter. You can also click on Open Jupyter Lab. It's just a different UI, but Open Jupyter is what I use. Something that someone shared with me on the last stream was that you can actually push code through Jupyter notebooks through their console. So before in the last stream, I downloaded all of these files or copied and pasted them and recreated them. Don't have to do that. Turns out there's a way to do that. If you want to see more information about that, I want to credit that commenter. So go check out the other live stream and see how it's done. My issue from last week was after uploading the MNIST model, which kind of talks about how data will go through our neural network, what that data looks like, and then how it will be interpreted, I uploaded it wrong. I forgot to paste in the first line of the code, and so it didn't work. So I ended up having to delete this file, re-upload it, and then I ran my Jupyter notebook to create that SageMaker endpoint, and it worked. So for a refresher, we have that model, we coded up what it looks like and how data runs through it. Then we start to create our SageMaker endpoint. So we run through that, give it the data that we're interested in. We upload the data to an S3 bucket. When you run this pygementize mnist.py or whatever file you're doing, it works if you see the code output here. Before, we didn't see the code output, which I thought was a little fishy, but I didn't know, and so I didn't mention anything. But you need to see the code in order for it to work, so that's what failed last time. So this is all of my neural network code. Then you can run SageMaker on it, which is essentially creating that endpoint, and then start the training. So the training took a while. It usually takes maybe 5-10 minutes. Sometimes it takes longer depending on how many epochs you do. I did 6, that was the default. But essentially, once it's done training, you can see in the output the loss. So the loss is essentially the error, or if you're running through the data, through the training and test data, how frequently is it correct versus incorrect. So after the first epoch, after the first round of training the model, it was 91% accurate. The second time was 94, third time was 96, and so on until we ended up at 97. I can certainly continue to run it, but 97 is certainly good enough for me, especially for this experiment or prototype. So ended at 6 epochs. Of course, if I wanted to get my accuracy up, I could increase the epochs. Oh, my sister's on. Hi, Cassidy. So we ended up getting our 97% accuracy with 0.098% loss. I shouldn't say percent. This would equate, yeah, it's 0.09 average loss, which means that our error in the model is very small, almost negligible. And then we can deploy the endpoint. So I already deployed the endpoint to my medium-sized instance type, And now we can utilize this input.html, which ends up just being this drawable trackpad, it's not working here, to draw numbers, handwritten numbers, and then see how our model interacts with them. So it's numbers 0 through 9. Don't do like 21 or something because that would make it confused. But let me just show you. So if I draw 7 here, and then I run this last block of code, you can see we're importing a NumPy. We're converting the data from this trackpad to a NumPy array. We're putting it through our predictor. We're getting a response from the predictor, and then it is printing our prediction. It is printing it'll actually give us an array. So it's giving us the maximum accuracy number in that array, which equates to 7. If that doesn't make sense, I'll show you a little bit how it works. So first, we'll clear it. I'll draw an 8 here. And then I'm going to add some print statements. So let's take a look first at what this image data looks like. So it's pretty messy, but you can see it's a bunch of zeros and ones. I'll show you what this looks like formatted, and you're gonna be really excited because it's just a really cool thing. So if I put all of this on one line, it might take me a second, but you'll see that you can actually get the exact tracing of the number that we drew on the trackpad as an array. So if you can't already figure it out, the ones are the black space, the zeros are the white space, and hopefully, sometimes you have to squint a little bit, just like when you see ASCII art, you kind of have to squint to try and see the number, but if you can, it's kind of starting to come through. You can see the 8 being drawn with the ones. And I believe that trackpad gave me a image dimension that matches what the size of the trackpad is, so it's just scaled. So a couple more lines, let me just finish it out. Boom, done. So it might be hard to see. Hopefully you can. If you can't, I'm sorry, but you can kind of see the outline of this 8 here with the ones. Again, you might have to squint a little bit. You might have to step back to see it well. But again, here are the ones. If you kind of follow the tracings of the ones, you can see my drawing of the 8. So that's what this image array looks like, this image NumPy array looks like. And that gets sent to the predictor, and then it quantifies it as a numerical value. So let me just comment this piece out, and then we'll print what the response is, so you all can see what the response looks like. I know that array might be a little bit hard to see. Again, you kind of had to squint and try and look at the ones. The ones show what the handwritten number is. But if you can't see it, you can just trust it really resembles what this 8 looks like. So I'm just gonna quickly run. And now we have this array. So the numbers don't really make that much sense, but let me explain. So essentially this is an array of size 10. Each index represents the handwritten numbers 0 through 9. And in my model, I could certainly adjust these numbers, add a multiplier to make it look more like percentage of accuracy, but I don't really need that. Of course, you can go into the code and fix that. That would just be in the training piece of the code, but this represents how confident the neural network is that handwritten digit is a 0. So it's very clearly not a 0 because this is the smallest number. Jeff Blankenberg is on. Hi, Jeff. Jeff sees a bird. That's funny. Jeff was one of my old coworkers at Amazon and is arguably one of the coolest people I know, my sister included. And I meant to throw shade. So this index represents the 1, this one represents the 2, 3, 4, 5, 6, 7, 8, 9. So as you can see, the highest number in this array is of index 8, representing digit number 8. And so the neural network is most confident that this handwritten number is an 8. So then it would print that, and we can see that 8 is correct. That's exactly what it was. Let's do something a little ambiguous just for fun. Let's do a funny looking 2 and then see what it says. So it still definitely thinks it's an 8, but as you can see, the index representing the digit 2 and 8 are very, very close, also 3. So the neural network wasn't really sure. It thought, okay, maybe it's a 2, maybe it's a 3, maybe it's an 8. It came up with 8. Again, maybe if we did more epochs, it would actually look like a 2, but the number was bad, so I don't blame it. Let's do something funny just for kicks. We'll do a smiley face and see what number it thinks it is. And it thinks it's a 0. So that actually makes sense, because if the symbol doesn't represent any number, there are various ways in the neural network to say, hey, default to this. So it might be defaulting to 0. It probably isn't. It probably just thinks it's a 0, but we can rest assured that it would be able to recognize 0. So it's fun. You can play around with this a little bit. It's definitely, you can get creative, as you can see, with how you can build on this neural network. If you want it to identify more than the 0 through 9 digits, you certainly can. It would just be increasing what the model is able to identify, but that also means finding data, as much data as the rest of these digits, assigning the number, let's say 10 or 11 to them, and then adding them on to your training output. Can you do backwards numbers? That's a good question. I don't actually know if I can draw a backwards number. I'll try drawing a 9. I think that, yeah, that's a 9. It thinks it's an 8. So 8 is the popular number. It definitely actually really thinks that this is an 8. So, I don't know. Maybe if I did a 9 with a tail, it might think it's a 9. Still thinks it's an 8. Yeah, I mean, the backwards numbers probably doesn't really exist in the data set, so it's not a surprise that it doesn't know how to identify it, but if anything, it's interesting just to see what it finds the closest number to be, or the closest representation to be. But it's very good with forwards numbers. Okay, so once you're done experimenting with this, if all of that looks good, then we are ready to deploy this model. If you weren't ready, like I said, you could mess around with the code, mess around with the epochs to try and get it more accurate. This is good enough for me, so I'm going to jump back into Amazon SageMaker. This is my, again, notebook instance, and then I'm going to scroll and find this endpoints piece, this endpoints tab in the toolbar. So this is under, again, inference and then endpoints. So you can see we have this endpoint that I created last week. If I reran all of this code, a new endpoint would appear, so I actually probably want to do that. So I'm going to run all of this just to make sure it has my most up-to-date code, but I'll take a look at this endpoint as the example, and then when it's done running, we'll come back. Let's see. Oh, hey, Nick is here. Hi, Nick. So Nick is also a good AWS expert. He's saying that rotations are a common training set augmentation technique because orientation is significant and becomes encoded into the model. Cool. Interesting. Yeah, that's great. Okay, so anyway, let's take a look at what this endpoint has for us. So as you can see, we have a URL representing this endpoint. We have an ARN, which is again how I can connect certain things to each other. These are both things that I will need for my Lambda function. So I am definitely going to reference this later, but you can see it's in service, which means it is good to use. So now I'm just opening a new tab with this. Now I'm going to head over to Lambda. So Lambda is something that as you can see, I've created some Alexa skills with it. I've created some instances of this code with it, some things with the Tectron 2, but it's essentially a way to host your code. It's utilizing these Lambda servers to make your code runnable, and then you can connect them to other AWS services. So I'm going to create a new function in AWS Lambda, and I'm going to use Blueprint. Blueprint is essentially just a template. So there are various templates here. I'm going to find the microservice HTTP endpoint Python. I think that's what it's called. Yep, here it is. So this template, this blueprint, is described as a simple backend read/write to DynamoDB with a RESTful API endpoint using Amazon API Gateway. So essentially what I'm saying with this template is eventually I want this service to be connected to a RESTful API. So this will just give me the necessary functions to be able to set that up. Tom! Hi Tom! Thanks for joining! I appreciate you watching. Okay, so I selected this template, and then you can specify your function name. You can call it whatever you want. I believe in the blog post I called it like PyTorch Py something, but I'm going to have it match my notebook name so I can keep track of it. I named this one something kind of funky, so I'm just going to call this Maker Py PyTorch Sage function and roll with that. Execution role. So this is very similar to what we had previously done with SageMaker. It's just, again, assigning permissions. What can this function access versus not? So I'm just going to create a new role from AWS policy templates. You have to name it, so I'll just name it this and then role at the end. You don't have to add any other policy templates, just ensure that the simple microservice permissions are selected. API trigger, you can select create an API, or you can select a REST API that you've already created. I'm just going to do create API and then select REST API. Security, you can set this as open, meaning that, you know, and anything can access this, anything can access your API. If you're going to use this in production, I would suggest revisiting this aspect, but we're not doing that. We're just making a prototype, so I'm setting it as open for now. Then you can see it has this template code for us. So with a REST API, it gives us these options: delete, get, post, put. We might, Stuart, hi, how's it going? We might use these, we might not. We're not. I'm just going to do a post, I believe. So it has it here. Again, you can certainly create your own API endpoint to do various things. Ours is just going to send image data to the model and then send back a number, a digit. So we're not going to do very many fancy things. But again, it's good to read through and good to know, especially if you're trying to understand how AWS Lambda works. So with all that in mind, let's create our function, and we'll give it a second to create. We can check on our code that is running over here. We're on the first epoch of training, which is exciting. Again, if you see a number next to your runnable code block, that means it's done running. If you see a star, that means it's currently running. So we are currently trying to train our model to utilize that endpoint. And yay, back in Lambda, our function was created. I don't know why I named it that. I should have just named it something more simple, but whatever. Here we are. We can't turn back. So now you can see we have our function is created. We already have a trigger for API gateway, meaning if that API is triggered, it knows to jump into this Lambda function. So I'm going to scroll down and add an environment variable. So this environment variable will be something that is not visible per se to people who are accessing this function. This is also something that is kind of easy to change. Consider it like a global variable without actually explicitly putting it in the code. So this is actually where we need our endpoint to finish. So hopefully, and yay, it did finish. Okay, so the predictor is just running to finally create that endpoint. But this is where we actually need our endpoint URL back in SageMaker. So this might take a second to run. In the meantime, I'll just start writing the code, but essentially we want to get the endpoint name from our SageMaker model that was deployed to utilize in our Lambda code. So we'll set that again as an environment variable for us to use, but in the meantime, I will just write some code. So I know we used a template. I'm actually going to start from scratch because I think that that's a little bit easier. You can certainly use this template, but I like to start from scratch again because it's just kind of easier for me to understand if I iterate line by line. And I think you might learn more too. So the first thing that we want to do, I guess I'll keep the imports, and then if I use the imports, great. If I don't, who cares? The first thing that we want to do is we want to access that SageMaker endpoint. So I'm just going to call it endpoint. Major flex, thanks. I think I don't know. I think it just helps with learning. I also think that you guys probably know that I am reading from code on my other screen, so that's also part of it. But we're going to access the endpoint through our environment variables. So when I do create an environment variable, you can imagine me just calling it endpoint and then adding the value to it. This is done or being created, so I can utilize it now. But I guess, yeah, I can use it now. So we're going to be using this URL. I'm just going to use the last part of this URL. So right when it starts to say PyTorch training and then it has a date and timestamp, take that piece and then add it to value. So we're naming our environment variable endpoint. I can just call it like endpoint name. And then the value is this latter part of the URL. And again, I got this from inference endpoints, selected my endpoint that I just created after running this code, and then adding it to my Lambda function environment variables. So we'll save. Now we have this endpoint accessible to us. So I'm just going to access that environment variable first. Okay. So next I want to set the runtime, meaning how I want to run this code. So this is pretty standard, I think, to the AWS library, but you just do boto3 client and then select the service that you're using. For me, it's SageMaker, so it's runtime.sagemaker. Okay, so now we want to create a handler for this code. So I think the templatized version is just calling it Lambda handler, where we will take in an event and the context of that event. So if you can imagine, the event is the data that we will receive from the REST endpoint, and then the context is just the context of the event. So there are different ways you can access this. The standard way that I do is just with JSON. So I just do data equals JSON loads and then dump the event, which means give me all of the event characteristics but parse it as JSON. So then once that's done, we will just do payload. Payload is standard nomenclature, and then access the data because the request will come in as data first, and we can print that and see what it looks like. Okay, so I am probably gonna have to mess around with this, especially depending on how I create my REST endpoint. When we get to that aspect, there are different ways we can do it. We can ask the web client to send us an array of the image, similar to what we saw in the runnable notebook. We could also just ask them to send us the image straight up and then parse it on this end. We can ask them, to essentially send us data in various ways, but I just want it to start as data, and then I'll send that data to SageMaker and we can manipulate it later here. So for now, again, we're just taking that JSON array, which would, kind of look something like this, if you can imagine, and then maybe have our image data here, and let's just say it's an array of zeros and ones. So we would take that and then send that to SageMaker, if you can picture it. Actually, this is Python. This isn't Node. I'm very used to writing in Node.js. Okay, so now we want to, like I said, send this payload to SageMaker and then get a response back. So we'll just call this response, and we'll say runtime invoke endpoint. So this function has various parameters that we need to fulfill. One is the endpoint name, which we specified in our environment variables as endpoint. We need to send the content type, which, like I said, I chose JSON. And this is pretty standard, again, for sending data to SageMaker. If you want to read about why these things are the case, I would suggest looking at their tutorials. Then in the body, we are going to send our payload. And then we can print what our response looks like. Once we have done that, we want to ultimately send whatever label we get. So if you can imagine, just looking at this, we'll get in our response an array, and so we want to get the maximum value of that array, or we could send the whole array. For now, I think for simplicity in reading, I'll just say that we send the response, and then we'll probably have to come back to this to edit it. But I'll save it for now. We can take a look at the various prints in CloudWatch and mess around with what it potentially looks like. Cool. So I think if this is ready to go, it's still creating, but maybe if I refresh. Yeah, it's still creating, so I'm not totally sure if it'll work. But we can certainly try it and test it out. So I'm going to take this number 8 that I wrote. I think we actually would probably need to convert it to an array. You can see that it has dots next to it right now. So I'm going to just print data, and oh, it looks like I said, it's still creating. So we might have to give it a minute, but I'm asking it to print data, so that way it doesn't come to me as a NumPy array, it comes to me just as a normal data array. Yes, and it's done. So let me draw my 8 again, because we'll just use 8 as our example. Print the data. You can see it's an array. It's a multi-dimensional array too, but yeah, I think if I do this, it'll probably work. Yeah. So I'm gonna grab this and then jump over here and create a test event. So essentially what I'm saying is if my web client sends me this array, then send it to SageMaker to parse. So I'll create a new test and just do like, I'll just call it test. And we want to create our request. So I'll just call it data and then put this in there. No! What did I do? Oh my gosh. Ugh. I have this problem all the time where I click the back button instead of scrolling. So we'll try it again. Test. Hello. Data. And then that array. Create. So my test is created, meaning that I'm going to send this event to my Lambda handler and we'll see what happens. So it failed, which is fine. The name OS is not defined. Did I not import? Oh, oops, I didn't import OS. So let me just do that really quick. I'll do this. No, we'll keep it alphabetical. Cool, so importing OS. Is there anything else that I didn't import? I don't think so. Let's try it. Dump is missing an argument, FP. JSON load, JSON dumps, plural. Test. Error occurred when invoking the endpoint is not authorized to perform this. Okay, so this is an issue with IAM probably. So whenever I get it's not authorized or there's not permission, then I usually assume that it's an IAM error. So I'm just going to make sure that IAM for SageMaker and for Lambda has access to each other. So let me go do that. Hey Alexis, how's it going? Thank you for joining us. Wow, she's so nice. Okay, so let me see. I used these things today, so I'm going to make sure we attach Lambda to my SageMaker. And I'm going to do Lambda full access again because this is a prototype, but if you had this in production, again, you'd probably want to edit it. I also have this execution role for SageMaker. I think that this one is probably old, but I'm going to still give it my full access to Lambda just in case. Hi Nilish, thank you for joining. Okay, so we attached those policies. Now I'm going to do that for Lambda, which I forget what I called that. Execution role. Looks like this one. And I'm going to attach a SageMaker full access. Hopefully that works. I think that's all I needed. Okay, yeah, that looks good to me. Let's jump back to our Lambda function and hopefully it works. So now I'm going to test. We got a fail. Failed to satisfy the constraint. Okay, that's fine. This is fine. This is good. So essentially what this means is that the data that came from the payload doesn't match what the model asks for, what the SageMaker endpoint asks for, which is fine. A great way to see how that data is coming through is we can click on logs. This takes us to CloudWatch. It's the logging system for AWS Lambda. So we can see our, where would this be? Shoot, I am blinking. Under CloudWatch, Lambda, no. Is it under log groups? Oh yeah, I guess it is. So if you go to logs under log groups, you can find your function. So here's mine. And you can see the log stream, this is the page it took me to. I don't know why I didn't just go for it. So this most recent event is the one that I just tested. If we went to the first one, then you could see that it just says OS is not defined. I can zoom in a little. It just says OS is not defined, which we saw and got, but I can check the logs for that most recent run. So as you can see, it printed our, let me scroll down, it printed our payload, or rather gave us that information, and then it gives us the error that appeared. So my guess is that it's probably because I added these extra brackets at the end, but I can certainly check. Oops, wait, what just happened? Oh, I deleted the quote instead of the bracket. So let's try that. Same thing. Let's see. Failed to satisfy. Member must satisfy regular expression pattern. Let's see. Oh, do I have to give it the image thing? I don't think I should. So quick way to gut check. Hi Jonesy. Hi Andrew. Hi Alex. Wow, so many people joined. Thank you all for joining. This is fun. We're figuring out an error right now. So it's, I guess at this point it's probably crucial to see what this image array looks like, because ultimately that's what we want. So it's this 4D array again, which is what we serve it. So right now mine is a 3D array, so that's probably the first problem. So I want to make this a 4D. We're sending the data. So again, we get the JSON dump. Let me just print heyo. Wait, didn't I already print the payload? Yeah. So we get the payload, and that to us looks like this 4D array again. But we want to make it a NumPy array. So that's probably my issue, I think. That said, we do send it as a JSON. Did I forget a semicolon? Oh wait, it's Python. Did you add a semicolon? No, that's not the issue. Really good try though. Okay, so, and let me just ensure we never get to, yeah, the response. That's fine. So, I could convert it to a NumPy array, but I don't actually think that that's crucial, but let's try it. Why not? So I'm just going to take this code directly because again, the predictor, as you can see, will want something that resembles this NumPy array, this image. So, oh, the thing is though, with Lambda, then I have to add the NumPy, because I think if I import NumPy as NP, I think that'll break. Oh wait, no it didn't. Wait, save. Test. Yeah, so I can't actually do that. So I need to set up my environment to where it will actually take in this data appropriately. I might come back to this, but I don't want to. What did I do wrong? Oh wait, access denied. Wait, no, this is old. Let me try it again. Let's see. Let me save, test, check my logs. Because if it's an access denied again, then that means it's not a problem with my code. It's a problem with my permissions. Nope, want to get another one. Here we go. Wait, when calling the invoke endpoint operation, one validation error detected. PyTorch training / invocations at endpoint name failed to satisfy. Oh, so my environment variable is wrong. Wow, that sucks. Okay, that's fine. I can fix it. I'm gonna get rid of this / indications. I think that's probably my issue. Save. Test. Failed. Response is not defined. I spelled response wrong. Save. Test. Unable to marshal response. But we got a response though! Okay, JSON is not serializable. That's fine. Okay, yay, fine. So, the issue that I had was that when I copied over this endpoint, I didn't just copy this piece, I copied / invocations, which you don't want to do. So you only want to copy over like what you see up here, or what you see here, or what you see here. You don't want to do / invocations. That would be wrong. All right, so let's look at our logs for that most recent run and see what response gets us. So we have this crazy metadata that I don't know. Unable to marshal response. I don't know what that means, but that's fine. We can do something to it. So the response we get back, probably it resembles, where am I? This. And then they do response to args max at axis 1, the first one. We don't want any of that. I actually know exactly what to do. So we have to read the response and decode what it is saying. I can show you, this is a Bodo core streaming issue. So if we just Googled this, I'm gonna just get a new tab up and Google this business. I've seen this error before. I know it's something with the string. So this will probably give us something. Yeah, so we want to do JSON dump. Although this got -1. I don't actually think that's right. Essentially, we have to do some JSON magic to be able to read what this response is actually saying. I think this is probably our best bet here. So let me jump back in here. So for response, I'll do like response cleaned, we'll call it. And then JSON load response at body, it will be for us, .read .decode to UTF-8. And I'll return this for now, but let's also print it to see what we're actually getting. Save, test. Yay! Look at what we got, guys! Wow! Woohoo! Okay, so what did we test on? I think we tested on the number 8. So, okay, this is exciting! I can't believe it worked. I can. So again, we get this array like how we did with SageMaker. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, which is the smallest number, biggest number I mean, which means that it has the most confidence that that number that we just sent was an 8. Thank you for coming, Andrew. Thank you. Can't you use slash using escape as it is a regular expression? I don't know. Whatever. We fixed it. It's working. Yay. Okay, so now we have Lambda working. Now I guess I have to decide, do I want to send this array to the web client or do I want to send just the digit? I'm pretty sure I just want to send the digit. So I'm going to get the maximum of this array and then send the label to it, meaning the index of that array. So I'll do that really quick, return, and then we'll close out our day and I'll talk about what we'll do next week. Okay. So this is, again, what our response clean looks like. So we want to get our prediction. Let me scroll up a little bit so you can see. Oh, I don't know if you guys just heard that, but my puppy is outside my office crying. I'm almost done, Kilua. Okay, she just wants lunch. She's not that sad. Okay, so I'm going to get response cleaned. The maximum of response cleaned at 0 because it is a 2D array. So I'm going to get the first index, which would be this array, and then I'm going to get the max of that array. So that should then, let's just, for poops, make sure that that's right. Save and test. Wait, why didn't it? Oh, because that's the output. Okay, so if I look in my logs, I should see, yes, there's my number here printed. Great, and I want to get the index of that because fortunately we only have a few labels and they're all associated to their index. Woohoo! So then predicted number, I'll call it, will be the index of prediction at this response cleaned. Cool? Cool. Okay, so response cleaned at 0 dot index at index of prediction, and then I can print the predicted number. Test. And it's an 8 in our response. Woohoo! Yay! Okay, so again, for poops, let's just do another number. We'll do 3. Let's run it. Okay, it gives us 3 there. I'm going to print this data again. Okay, so here's our array. So I'll copy this. Again, web client will send this to us. Let me configure this test event. I'm going to create a new one. I'll call this test for 3. Quote, close bracket, create, test, and it gives us a 3. Woohoo! Yay, very exciting. Okay, and it gives us a success. Great. So, what did we just do? Let me go back to my diagram. We deployed our PyTorch model on SageMaker, made sure it worked, made sure it tested according to the confidence that we would have hoped. And then we created a Lambda function to access that SageMaker endpoint and kind of take the data that the model gives us, parse it, clean it up so that way it is ready to send to our web application. So in next week's video, we're going to take this Lambda function, plop a REST API on top of it so that way we can use that REST API in our web client to publicly send and receive information from that SageMaker model. If that all sounds good to you, that sounds super good to me. I guess I could show you my bill right now. That might be helpful to see how much money it's cost me to keep this up for 2 weeks. So, preface, I've past the free tier for SageMaker. So, like I said, there is a free tier. If you're playing with this once, then you will probably stay within that free tier. But I've passed it, it's done, it's gone. So right now I've accrued a bill of $53.62 using SageMaker and the directory service. The directory service is to host my data, and then there's some tax. Again, this was me keeping it up for over a week, so if you do this all in one sitting, it shouldn't cost you this much. But when you don't use things, always remember to turn them off. You can do that in, let me show you how. If you go to SageMaker and you want to shut something off for the day, or after you're done tinkering with it, you can just go to Notebook Instances, click on your Notebook instance, and click Stop. You can click Stop, it'll stop it, then you can click Start, it'll start it again and make it in service, and you can play around with that. Cool? Cool. Awesome. Well, let me switch back to camera. Like I said, thank you all so much for watching. I hope you're learning something through all of this. I know I am. Messing around with AWS is always fun, but then again, messing around with PyTorch is fun too. So like I said, in next week, we're going to connect our Lambda service to a REST API using AWS API Gateway. And then the week after that, we'll connect it all to a beautiful web application, and you can see it running in kind of production, I guess. As always, if you have any tips or tricks that you want to share, please leave a comment. I love reading those. Those make me a better developer and the community better developers, so I appreciate it when you do. Yeah, that's it. Thank you all so much for watching, and I hope to see you all next week. Bye, everyone.